I Trupti. In this video we will going to look for FPL1 subject as per SPPU and UNIT-2 Introduction to Programming Language. So the syllabus is Programming Language, Introduction to what is Programming Language, and the start to the C language. So types of programming language, features of C, basic concept, structures of a C program, declaration, variables, data types, expressions, conditional expressions, different operators in C language, assignment operator, arithmetic operator, relational operator, logical operator, increment, decrement, precedence of operator, type conversion, scanf, and printf. So weightage for unit 2 is having, it will be having unit 1 and unit 2 will be having around 9 questions of 1 marks, and unit 2 will be having 20 questions based on 2 marks. It will consist of code snippet, evaluation of sequence, and expression evaluation. So instead of wasting too much time, we'll start with unit 2. What is programming language? As we know, any language which we use is used to effectively communicate to people with each other, like English, Hindi, Marathi, Spanish, French. So why we use this language? To perform effective communication between two different users or person. We use the natural languages. So in the same way, to perform effective communication between computer and the user, we should have the knowledge of the language which is understood by the computers. So because of that, there are different kinds of programming language. It is used to communicate instruction to the machine. The language acceptable by computer, it is called as a computer language or a programming language. The process of writing sentences is in such language is called as a programming or coding. Like whatever steps we want to perform, that steps are written in the form of code, so they are called as a program or codes. Using program, you can control activity of the computer, and there are different types of language for different tasks, each having some advantage and disadvantage. So here is the examples of different programming language we use: C, high level language, assembly language, machine language, hardware languages. So what are the types of computer programming language? There are basically only 2 types of computer programming language, that is low level language and high level language. Low level language is a language that corresponds directly to the specific machine, means by using low level language we can directly communicate with the machine, or which is very nearer to that machine. And high level language, any language that is independent of machine, means the language which is understood by the users or us, but it is not directly understood by computers. So in between, what we have in between, we have the intermediates or the translator, which will translate this high level language into the language understood by the computers. So there are different types of languages: low level language, high level language, okay, and the mid level language. The low level language, as whatever you are seeing, these are the examples of low level language. Everything written in zeros and ones or in the forms of some codes, but which is not understood, which is not able to understand by any user. It is understood by the CPU of the computer or the computers. So low level language, low level computer language are either machine codes or are very close to them. Computer can understand only the program written in the low level language. A computer cannot understand instructions given to it in a high level language or in English. Like if we say, hey computer, go and perform the addition of a plus b, it will not going to give the result because it don't understand what is the meaning of this sentence. Instead of that, if we give something which is understood by the computer, like whether we give the sequence of zeros and ones or assembly code, it will give us the response. So it can only understand and execute instruction given in the form of machine language, that is binary. There are 2 types of low level language: machine language, a language that is directly interpreted into the hardware; assembly language, a slightly more user friendly language that directly corresponds to machine language. This is example of machine language. Whole thing is written in zeros and ones. Machine language is the lowest and the most elementary level of programming language and was the first type of programming language to be developed. Machine language is basically the only language that a computer can understand, and it is usually written in a hexadecimal format or in zeros and ones. In fact, a manufacturer designs a computer to obey just one language, its machine code, which is represented inside the computer by a string of binary digit 0 and 1. The symbol 0 stands for absence of an electric pulse and 1 stands for the presence of an electric pulse. Since a computer is capable of recognizing electric signals, it understands machine language. Machine language, here instructions use a series of binary digit, that is zeros and ones or hexacodes. It is also uses series of numbers and letters, but they are also represented in zeros and ones. It is only language understood by the computer. It is machine dependent language and it cannot run on another machine. Like if I say, like I have AMD processor and my friend is having i7 processor, whatever language which I am writing on the AMD processor in the zeros and ones, it will be different for the i7 processor. For i7 processor, I should have to write the different program which is written in the zeros and ones. So depending on whatever machine you are using or whatever processor you are using, your binary code will get differ. The example of this binary language and machine language. Advantage of machine language: it is only one language which is understood by the processor. It requires no translator to translate the code into further any other language because this directly understood by the computer. It makes fast and efficient use of computer. It is directly understood by computer. It does not require any translator to translate the code. And limitation of the machine language is that writing program in machine language is difficult and time consuming for the users. For we, all binary or hexacodes needs to be remembered, and it is difficult to find error in the program at what particular line we had made mistake in the files of zeros and ones. Like this, we will not be able to see where we did the mistakes because we have a whole thing in the zeros and ones. It is difficult to correct and modify the program. Programmer should have the detailed knowledge about the hardware. So we'll switch to the next machine level language, that is assembly language. Here you can see whole this is the code of machine language. Everything written, something is written and some values are provided. So assembly language was developed to overcome some of the many inconvenience of machine language. This is another low level but very important language in which operation codes, what is the operation we want to perform, and operands, what are the values for that operation, are given in the form of alphanumeric symbols instead of zeros and ones. These alphanumeric symbols are known as mnemonic codes and can combine in a maximum of 5-letter combination. Like if I want to perform addition, so in short form I can write add for addition, sub for subtraction, start for start, label for label, and so on. Because of these features, assembly language is also known as symbolic programming language. This language is also very difficult and need a lot of practice to master it because there is only a little English support in this language. Most assembly language is used to help in compiler orientations. The instructions of the assembly language are converted to machine codes by a language translator and then they are executed by the computer. Here the translator, name of the translator which convert the assembly language into zeros and ones is called as assembler. Assembly language programs are translated into executable machine code or in binary code by using assembler. It takes the input as an assembly language program and it converts into the zeros and ones because our processor cannot understand any other language other than zeros and ones. So these are the examples of your assembly language. This is the opcode, what is the operation you want to perform on this data, and this is the opcode. Operands means what are the values you will give to perform this data. So this is example of assembly language. The format to write any instruction in the assembly language, that it will have two values. First is operation code and the second is operand. Operation code is the code which tells you about which operation you will perform, and operands will tell you about what are the values on which you will perform this operation. So here I am having add r0 100. So here I am telling that I want to perform addition operation on the data of r0 and 100. So r0 is the register name. Advantage of assembly language: it is easy to understand and use as compared to machine language. It is easier to modify, it is efficient, it is easy to find errors and easy to debug, means to correct the errors. Limitation of assembly language is also machine dependent, like whenever we switch from machine to machine or whenever we change our processor, our assembly language will also get changed. The programs written in one machine cannot be executed on another machine. Executed means we will not get the output of that program. Writing assembly language program is difficult and time consuming. So this is about the low level language, assembly language, and the machine level language. They are a bit difficult and they depend on the what is the machine we are using or what is the CPU or processor we are using. If we change our processor, so everything whatever we made the efforts for writing the program, we have to make the same efforts again and again if we are changing our processor. So the next type of programming language is the high level language. This is one of the example of high level language, that is, this is example of C language. So high level language allows people to write program easily in their own native language. It uses English words, mathematical symbols rather than mnemonic codes. HLL or high level language deals with variables, arrays, objects, arithmetic or boolean expressions, subroutines and functions, procedures and threads. The program written in a high level language must be translated into machine level language. Why? Because our processor is very dumb machine, it cannot understand any other language other than zeros and ones. So high level language is easy for us, easy and readable for us, but that is not understood by our computer or by our processor. So what we should have in between these two, we should have something which will translate the high level language into the low level language, that is machine language. So these translators are called as compilers and interpreters. High level language, the examples of high level language is C, Cobol, Pascal, Lisp. The compiler, what is the task of compiler here? It takes the input as high level language, it takes the whole program. When we give the whole program, it will be given to the compiler and then it convert the input program into the binary. If it does not have any error, like high level language code will be get converted into the binary or object program. So this is example of our very basic C program to print the hello world. This is our program and whatever output we are getting, that will be the hello world. So if we are having error in between, like I have written this thing which is not correct according to C language structure, so it should give you the error and it should not generate the binary file. So if you're not having binary file, you will not get the output. So this is the example, like if your compiler will not give you the output unless and until you will correct the error in your file. So this is the file which is not having any error, so directly compiler given you the output, and this is file in which you are having mistakes or error. So what compiler will tell you that, okay, go and first of all correct this error and then come back to me, then I will give you the output. Then what is interpreter? Compiler and interpreter. Task of compiler and interpreter is to convert the high level language into the low level language. But what is the difference then between compiler and interpreter? So interpreter is one of the translator which has a more important advantage over compilation. The data and source program are input to the interpreter instead of producing any object module as in the compilation. The interpreter directly produces result by performing operation of the source program on its data. So I think you will not understand, so we will take this with the help of example. Like whenever you do any sign up form, you go to the sign up form, like this is the code which is understood by any high level language. So whenever you fill the data, you should have to give the values to the receiver, and then the receiver will give you the response. Suppose I am having the high level code here, so what I will do, if I am typing something and I made on any line, so instead of giving you the whole list of errors at what particular line you are generated mistakes, after you give whole your page and then it will give you error. So this thing will never happen. Like whenever you go and whenever, suppose in the mobile field you type the name, so it will immediately give you the error. Instead of waiting, like you will write the whole form and you will submit and then okay, then I will give you the list of mistakes what you have made. No, it will immediately give you at what particular line you have made the mistakes before you press the submit button or sign up button. So this is the task of interpreter. I think you have understood the basic thing. Like the difference between compiler and interpreter is that compiler will wait for giving the whole program is given to the compiler, and compiler will find line by line for whole the program what are the mistakes. Interpreter does the same thing but in exactly opposite fashion. It takes one line at a time. It finds the whether this line is having error or not. If it is having the error, so it will immediately give you the response or error list. Like I'm typing before submitting this form, so here I have made the mistake, so immediately my interpreter will give me the list like, hey dude, you made mistake here, so don't go for sign up. So this is the task of interpreter. It will not wait like you will give the whole file and then okay, I will give you the mistake list. Some of the examples of high-level language programming language are Fortran. It is oldest programming language developed by the team of programmers at IBM and was published in 1957. Fortran stands for Formula Translation, as it was designed to allow easy translation of math formulas into the codes. Cobol. Cobol is earliest high-level programming language. Cobol. Co stands for common, BO stands for business-oriented, and L for language, common business-oriented language. Pascal. Pascal is procedural programming language. Snowball. Snowball is series of computer programming language. Stands for S for string, O for oriented and symbolic language. Snowball stands for string, oriented and symbolic language. Lisp stands for list processing language. Octave, GNU Octave. Advantages and disadvantages of the high-level language. Advantages of high-level language is that high-level language are user-friendly. They are similar to English and use English vocabulary and well-known symbols. They are easier to learn. They are easier to maintain. They are problem-oriented rather than machine-based. A program written in a high-level language can be translated into many machine languages and can run on any computer for which there exists an appropriate translator. A language is independent of the machine on which it is used. That is, the programs developed in a high-level language can be run on any computer text. Disadvantage of high-level language is a high-level language has to be translated into machine language by a translator, which takes up time. The object code generated by a translator might be inefficient compared to an effective assembly language program. Characteristics of a good programming language is that some of the programming language are popular and some are not popular. The success of programming language is based on the following points. Like you say, what is the best programming language in between C, C++, Java, Python and so many things. So programming language should be simple and readable. Programming language should be portable. Programming language should be general. That is, it allows writing wide variety of programs, thus helping programmer to get expert in many diverse programming. Programming language should be widely available. That is, it should be able to provide translator for entire machines for all operating systems. Programming language should be efficient. That is, program written in programming language should be efficiently translated into machine code. Programming language should provide modularity to develop the program. Depending upon the type of application for which a programming language has been designed, the language must be suitable to its environment. So like you understood, like this C is good, C++ is good, Java is good programming language. So which language you will select for writing your own code? So selecting a language out of many available language for coding application. So how you will select whether you will go for C, C++, Java or PHP. So many languages are available for coding the particular application or subprogram. So how to select the suitable language? Following are some of points can be considered while selecting the language to code the application. If application is operating system intensive, means that if you want to perform any program or any software which is very nearer to the operating system or which is based on the system programming, then surely go for C or C++. If application is operating system independent, then choose the Java programming. It doesn't matter like which operating system you are using, whether you are using Windows, Apple, or any Linux or any which operating system. In that case, like if you want to develop the application, you don't bother about which OS you are using, so go for Java programming. And it is open source, like if you want to make the source code of that freely available to your all the users, so in that case go for PHP is the best option. There are multiple languages found suitable for application areas. The language selected should be one that is easy to learn and use for you, because you are the only person which are choosing the language. Depending upon the size of application, programming language are selected. While developing the web page, Java server pages, JSP, PHP or HTML or any other scripting languages are preferred. If there are multiple languages found suitable for the application areas, the language selected should be one that is best known to the programmers for you. Like you will be going to code the program for like any program for like XYZ problem, you have the code present in C language also, C++ language also, and in Java also, but you are very familiar with C language, okay, then go for writing the code in the C language, don't go for C++ and Java. For large organization, the choice of language might involve factors such as how easily the program can be ported to different platforms. Okay, this is basic about the programming language. Then we will switch to one of the high level language that is very basic, or that is backbone of every programming language. Not every, but nearly about most of the programming language, that is the C language. So what is the C language? We will see the evolution of C language. Before C, we are having Algol, CPL languages, and then C comes afterwards. So the C was developed by the Danish Ritchie in the year 1972, and it was influenced by because of the evolution of B language, Algol language and Fortran language. He found that there are some of the mistake in this language. Okay, we can make the addition of some of the codes and we will make the new programming language. So the C language was influenced by B language, Algol language, Fortran language, and it influenced, or it base of the C language is used as the language for the other language. Like it gives the basis for the evolution of C++, C#, Java language, Perl, PHP, and so many things. So father of C language is Danish Ritchie, who made the C language. So C is the programming language developed at AT&T Bell's Laboratory of USA in 1972. It was designed and written by a man named Danish Ritchie. Possibly why C seems so popular? It is because it is reliable, simple and easy to use. C has been already superseded by languages like C++, C# and Java. So for when you go for understanding any language, you follow the different steps. Like if you want to learn English language, what do? First of all, you go for what are the alphabets in English language, like A to Z. Then how we will write the words. Okay, once we write hi, hello, these are the examples of words. Once we write these words, how we can make the sentences. Then when we learn about making sentence, we go for writing the paragraphs. So in the same fashion, we learns the basic about the C language. The first step is that we should have the knowledge about alphabet, digits, special symbols which are allowed in C language. Then by using this collection, what the names which we can make, what are the words which we can make, they are called as constant variable keywords. Okay, now the task is done. Now what is the next step? Next step is that we should write the sentences. So they are called as an instruction, and the collection of instruction makes a program. So the whole this will give you a single program. So analogic to learn English language is the classical method of learning English is the first learn alphabet or character used in language, then learn to combine this alphabet to form words, which in turn are combined to form the sentences. Sentences are combined to form the paragraphs. Learning C is similar and much more easy. First step, to write programs you must know what are the alphabets, numbers and specific symbols are used in C, then how using constant variables keywords are constructed, and then finally how these are combined to form an instruction, then a group of instruction is combined to form a program. Some of the features of C language: it is robust language and language which is rich set of built-in functions and operators that can be used to write any complex program. C compiler combines the capability of an assembly language with the features of high-level language. Programs written in C language are efficient and fast. It is many times faster than the basic programming language. C is highly portable. This means that the programs once written can be run on another machine with little or no modification. Like today I am making the C program in my machine, and tomorrow I am making the program of C printing hello world program, the same program which I made in my machine. I am writing the same code in your machine. So to get the output, we don't have to make any changes in that code. The same code will be get executed on different machine. Another important feature of the C program is its ability to extend itself. C language is the most widely used language in operating system and embedded system development today. So these are some of the features of the C language, like portability, simple, powerful, fast and efficient, modularity, compiler based, platform independent, use of pointer, middle level, structure oriented, case sensitive, syntax based. So what is the basic structure of a C program? The basic structure of a C program, it should have first line, the documentation section. It tells you about what is the program you are writing. So for this we use the comments. Comments are the non-executable part of your program. Single line comment is written by using the // If you want to write more than one lines of comments, then you should go for typing /*, multiple lines, star and slash. Okay, then the link section. If you are writing the codes in your program, but like suppose this is the function, but here I have not defined what is the printf, what it will look, or so this the code of this is present in this file. So I should link that file by using #include stdio.h for using printf function. Then definition section, whatever things you are using, you should declare this. Or definition section, we can have #define. In global declaration section, we will globally declare the variables. Then we have main function. Inside main you have two parts. First part should be declaration part, and second part should be the execution part, and then subprograms. And the last part is subprogram section. Here you can have more than one function. Every C program should have only one main function. Here every program has only one main function. Every C program has only one main function, at most and at least only one main function. The first part should be the declaration. Whatever thing you are declaring, you should declare all on the first line, and then whatever things you want to get executed, that is written after the declaration of this. The simple program, here it's written that this is documentation. We'll see the line by line. This is documentation section. This is telling me some comments which are not for which we will never get the output. Now here we are linking these files because this function, printf function, is present in my stdio.h file. That's why we are linking that file. Then this function, and the in void main we have written this, and so on. So we will see this after some time. So don't get worried if you are not getting something, or it's very hectic to understand this thing. Now hello world example. A C program basically consists of the following parts: preprocessor, commands, functions, variables, sentence statements and expressions, comments. Let us look at a simple code that would print the word hello world. So this is the simple C program which prints the hello world on the screen. I want to write the hello world on the screen, so I will not write the hello word in the program. So the thing hello word should be get executed on the output. So we should write the hello word inside the printf. Okay, here inside the printf we have written the hello word, but this printf function, this code for this is available in stdio.h file, this file. So that's why we should include #include stdio.h. Then we write the main function, because whatever things you want the output should be getting output of that you should write inside the main, and then this is the hello world. So when you compile this, you will get the output as hello world. The same thing I've written in the another program. So this is my comment part, a comment. Now this file stdio.h file I've written because the code of printf is present in my this file. So stdio.h is the source text file, definition of function main. So code for printf is present in stdio.h file. .h stands for header file, std stands for standard, I for input, o for output, and .h for header file. All .h files consist of the code of some of the function which you require, and this is the main function, definition of main function, the code for main function. This is the line which will give you the output on the screen. Now my one line is ended, so I will write the semicolon to denote the end of a particular line in my C program. The semicolon is the statement terminator. All statement in C are terminated with the semicolon. This curly braces denotes that this is opening curly brace, this is closing curly brace. What it will tell you, whatever you have above this, that is opened here, the above the curly brace I have main. So it will tell me that okay, so here your main, something which you are written above, that is getting started. Now write the whole code, and whatever things you are started, that is ending here, so that is closing curly brace. So here the braces defines the function body because they are not nested in another pair of braces. The program statement can only be written inside the function. So in simple words we can say that whatever things you want to write that, but to make that a part of this, you should write inside the opening curly brace and closing curly brace. So this statement is the function call. This printf is the call to the printf function. How you will compile and execute the C program. Let us see how to save the source code of a file and how you will compile and run it. So before actually starting this video, I will suggest you please go and study and see my previous video based on FPL1. So some of the concepts it will be get cleared for you. Now let us see how to save the source code in a file, how to compile and run it following at the simple steps. Open a text editor and add the above mentioned code in the hello.c file. Because you're writing C program, so your extension should be .c. Type the whole code and then compile by using hello gcc command, gcc hello.c, your program name, that is hello.c. And to get the output of that, I have not given what is the binary file name. After you compile, what is the name of file in which I want to store. So by default it will store the code in the file a.out. If there are no errors in your code, your binary command prompt will take you to the next line and would generate the a.out executable file. Now type a.out to execute your program in such a way that ./a.out, so you will get the output of your program. Make sure that GCC compiler is in your path and that you are running it is the directory, in the directory containing the source file hello.c. The preprocessor directive, all preprocessor directives begin with hash, this word, and it should start with the first column. So these are called as a preprocessor directive. Why we are using this? These are the names of file in which we have the codes of some of the functions. So what this line will, how this line will be get executed. Instead of this line, at the time of compilation, full code whatever present in this file will be written in your file. Whole code will be written of stdio.h, and then whatever lines you have after that, this line will be written after that. So I think you understood the thing. Okay, so it should start with the first column, and the use of angle bracket around the header file indicates that the header file is to be looked for on disk, which stored the rest of the C program. Like if I'm using this, then if I'm using this, I will include the file which is currently present in the file where I have installed my C compiler. And if you're writing hash include and okay, this is not double quote, file name, closing double quote. So it tells you that whatever folder, in whatever folder you are currently present, there, go there and look for the name of the file you are typed. So this is used for the current directory, and this brackets are used for the parent directory where your compiler is installed, and this is used for where you are currently present. In that folder, look for the name of this file. So we will start. Okay, this is so boring, so instead of just reading the theory, so we'll start how we can write our own C program. So instead of starting directly jumping on the code, we'll see what are the different characters or the alphabets which are allowed in the C programming language. So alphabets, all the alphabets from capital A to Z, small a to Z are allowed, with also digits 0 to 9 are also allowed, and some of the special symbols are also allowed in C language. Means you can write these things in your C program. It will not bother key, you're not using this. Okay, so a character denotes any alphabet, digits and special symbol used to represent information. The above table shows that the valid alphabets, numbers and special symbols which are allowed in C. Means by using this you can make a program. So some of the ASCII values here written, like whenever we press any value on the keyboard, so what is that value we store in our computer. So ASCII value for A to Z, capital A is 65, ASCII values for small a is 97, for capital Z is 122, for capital Z is 90, and ASCII value of 0 is 48. And some of the special symbol other than this range are all the symbols which are present apart from this range of your alphabet and digits. So these are the special symbols. Then we'll see what are the C tokens. Tokens are the simple things or entities which forms the collection of your program. So in C, what things you can have keywords, like some of the words whose meaning is already defined, some of the identifiers, some of the names which you are providing, like I want this name in my program, so they are called as identifiers. Some of the values, some of the strings, some of the special symbols, and some of the operators. These are allowed in C program, and whole these single entities or single things, objects or things, we can say that as C tokens. So this is already discussed. So we'll see what is constants, variables and keywords. The alphabets, numbers and special symbols, when properly combined, it forms a constant, variables and keywords. So a constant is an entity that doesn't change, whereas a variable is an entity that may change. This quantity can be stored at a location in the memory change. A variable can be considered as a name given to location in the memory where the constant is stored. Like you are typing 3x plus y is equal to 20 in the above equation, 3 and 20 cannot change. If you're writing this equation, whatever thing you're doing, like if you're doing the mathematical operation, this 3 will never get changed, this 20 will never get changed in the whole life of this equation. But you can change, we can assume any value of x and y. So here 3 and 20 are known as the constant, and x and y are known as the variables, because these are just name, but later on you can change the value of x and y with any numbers. So like the thing is that variables in C programs are the names which are given to store in the future whatever value you want to perform. Like if you want to perform C is equal to A plus B, so here instead of writing A and B, what you will have, A and B will never get added. What you should have value as 10, and suppose we will take example of value of B as 20. So when you give 10 plus 20, only then your addition will be get performed. You will get result as 30, and that will be C is equal to 30. Okay, but in there we cannot say like 10 plus 20. We want to make that as a equation, that as a. So another time we will take value of A as 20. So what we will need some location. Suppose this is my main memory, so I should have some of the memory for that A. So logically whatever name you are giving, like this will be the name for a. So this is just the name, but what we are doing, we are just skipping some of the memory for that. So this is called as a variable. Okay, we'll clear this. So the C constant can be divided into two major categories: primary constant, secondary constant. These constants are further categorized as shown below in the next slides. C constant are of two types: primary constant are of integer, real, character constant, and secondary constant can be array, pointer, structure, union, enum. These are the higher concept. We'll first see only the primary constants. So constant can be numeric or can be character. So numeric constants are integer values 1, 2, 3, octal values, hexa values, real values 0.082, exponential form. And character constants are the characters or a collection of characters and some of the special characters. So these are the characters constants, and these are the numeric constant. Here this is important thing: backslash character constant, or we say the escape sequences. For going on the new line we use /n. For having horizontal tab we go for /t. For vertical tab /v. For form feed we go for /f. For alert, audible alert, we use the /a in our C program. So what is a C constant and literals? Constant refers to the fixed value that the program may not alter during its execution. These fixed values are also called as literals. Constant can be of any of the basic data type, like an integer constant, floating constant, character constant, or a string literal. There are enumeration constants as well. Constants are treated just like regular variables, except that their values cannot be modified after their definition. Rules for constructing integer constant: an integer constant must have at least one digit. It must not have a decimal point. It can be either positive or negative. If no sign precedes an integer constant, it is assumed to be positive. No commas or blanks are allowed within an integer constant. The allowable range for integer constant is -32768 to 32767. What we are doing here, we are just talking about the values which we can assume as integer values, means the values which is not fractional. This is just the decimal value, like 1000, 1000, -200, anything can be integer constant. Then these are the, this is legal value, this is also legal value, this is also legal value, this is not legal value. Why? Because here O stands for, whenever you are typing value, O, if you're writing first of all 0, sorry, not O, 0, then whatever you are typing after that, it is the octal number, it is considered as an octal number. So if you type 7, 6, so that will be correct. Like octal number, take at each digit number should be in between 0 to 7, so that is octal number. So this will not be accepted. Rules for constructing real constant: a real constant must have at least one digit. It must have a decimal point. It could be either positive or negative. Default sign is positive. No commas or blanks are allowed within a real constant. In simple word, any fractional values which you want to use as a value, so that is called as a real constant. So these are some of the fractional values. So, and the character constant, whatever constant or whatever value we want to use as a character, we should write within a single quote, and in single quote, opening single quote, single character, closing single quote. So this is called as a character constant. And there are certain characters in C that represent special meaning when preceded by a backslash. So these are called as escape sequences characters. So \n, it reserves some meaning for the new line, \t for the tab, and so on. Rules for constructing string constant: if you want to make the string is generally a sequence of character followed one after other, or in simple words, statement or words can be written as a string in the C language. So to write that, we should write opening double quote, whatever things you want to write, hold that thing, and closing double quote. So that will be considered as a string. So variable, we will see what is a variable. A variable is a name that may be used to store the data value. Unlike constant, variable are changeable. We can change the value of variable during the execution of the program. A programmer can choose a meaningful variable name. So what is the thing here? I want to use this area of main memory for my further use in my whole program. So for this area, I don't know what is the exactly address of this location, so I will just give the name as x. So in my program, C program, we write the int x. So here x is called as variable because this is used for storing some values which is of type integer. So this line is called as a declaration. Here x is some name which is in future will store some integer value, and for this variable, for this name, we also have some memory allocated in the main memory. So this is generally the variable. So type of C variables, the types of variables that is it can support depend on the types of constant that it can handle. So if you want to store the integer value, go for integer variable. If you want to store the real values, go for real constant. If you want to store character values, or go for character variables. So the rule for constructing the different types of constant are different. However, for constructing variable names of all type, the same set of rules are applied. The first character in the variable name must be alphabet. First character should be alphabet, digit or underscore. Okay, you cannot use other than that any special character. The variable name in any combination of 1 to 8 alphabet, digits or underscore. Variable name must not start with a digit. Here it's I think this is not the correct. Okay, the first character of any name, like if I'm typing name, so this is allowed. This is allowed. Here first character is S, which is alphabet. This is also allowed. This is also allowed. Okay, but the mistake can be, we can say, like if you are typing name of variable as $xy, so this is not allowed because dollar is some other special character, so this is not allowed. So the variable name must not start with a digit. Keyword are not allowed. Keywords, variable names, keywords are not allowed because keywords are some of the words whose meaning is already defined and we cannot use them for our use. So no commas and blanks are allowed with the variable name. No special symbols other than underscore allowed. So these are some of the examples. So these are the examples of variable declaration. Like here I want to use this name, but I want to store only the integer value in this, so I will type int, I will type this value int si. Okay, si underscore int, and I also want to store this as another value, this as another name, but here I want to store integer, so I will use the same thing, this line. Declaration of a variable. Declaration of variable must be done before they are used in the program. Declaration does two things. It tells the compiler what variable name is, and it specifies what type of data variable will hold, and also it allocates some memory in your main memory, that is in your RAM. So here this is the variable declaration. What I'm doing, I'm using name A, B and sum for performing some tasks, but I'm clearly mentioning that okay, these are the names, and in future they can store only the integer type of values, they cannot store other than integer values. So when I'm typing this line, along with that A, B, C are getting stored in your main memory. So this is like area for A, this is for B, and another this is for sum. So the area in main memory is reserved for A, B, C. When you type this line, variable name are also given, and along with that you are clearly having knowledge that this can store only integer values, other than that you cannot take any values. If you are having other than that any other values, so you will, compiler will give, hey dude, you are used integer other than integer, so you are having mistakes. So what is a keyword? Keyword are preserved words that have special meaning in C language. The meaning has already been described. These meanings cannot be changed. There are total 32 keyword in basic C language. These keywords are, some of these are the keywords which we normally use: auto do, while, loop, while, for, if, else, case, switch case, size of, go to, register, return, int, void, char, and so many things. Identifiers simply the name we give to anything, for any function, for any variable, for any array, for structures. In C language, identifiers are the names given to variables, constant, function, and user defined data types. These identifiers are defined against set of rules. The rules for with using the set of rules we can write the identifiers. Rules for an identifier, like whatever names you're using, that can only have alphanumeric characters and underscore. The first character of an identifier contain only the alphabet and or underscore. Identifier are also case sensitive, means if you're typing name and this name, this is the different thing and this is the different thing, they are exactly different names, so these are the two different identifiers. Keywords are not allowed to be used as an identifier. Like identifier simply means what are the names which we want in our program for storing any values, so we cannot use keywords, the words which are already defined by the compilers. No special characters such as semicolon, period, space, slash or comma are permitted to be used in as identifier. So these are some of the values. So we will see what is the data types. So what is this? We will understand this. Like, this is my main memory or RAM, we can say random access memory, main memory, volatile memory. So here I want to, in this area I want to store some data and I want to reuse that data again and again. So I don't know exactly at what particular location my RAM inside my computer, my RAM is having exactly free space. So what I will just give the names. Look, A and B are some of the names I am giving to you by, like, we can say like int A by program. So these are the names. Find the area in memory which is free and give the name, give the address of that, or assign that with the A. And in future, if I tell you that value of A is this and this and this, so you should store that value in the area, in the memory area of my A. Okay, this is the data, this is the variable name, and the type of data is the name which tells you about the what type of value you will going to store. So here I have written the int A. Here I have written int A. So I am clearly specifying that in main memory where I have A, it will only store int, it will never store char other than int. So here, this is the thing which I am using. So data types specify how we enter data into our programs, what type of data we will enter. C language has some predefined set of data types, and to handle various kinds of data that we use in our program, these data types have different storage capacity. C language support two different types of data types: primary data type and derived data type. Primary data types are fundamental data types. These are integer, float, character, void. And derived data types are the data types by which uses the collection of primary data type or the concept of primary data type to make the new data type. So these are arrays, functions, structures, pointers, and this are discussed in the latter. So primary data types are character, integer, float, and void. Character can be written as character, signed char, unsigned char, signed int, unsigned int, and short int, long int. Float can be written as float, double, long, double, and void. So these are the data type and the range of data types for the 16-bit computer. This is for 16-bit compiler or computer. Size and range of int, short, long are compiler dependent. So if you are going for 32-bit compiler, your int size will be get changed. So instead of this, you will be having value as 4. So this is the range of my signed char. And for any character you will require 1 byte of memory. 1 byte is equal to 8 bit, and For int you will require 2 bytes in your 16-bit compiler, 4 bytes in 64-bit compilers. I will suggest you to pause your video here and read all of this range as specified here, and this is only for the 16-bit compiler. This may be asked in your exam. Okay, now we will proceed. So how we can say that what is the size of the int or any other thing? So we can say that one byte is equal to 8-bit, okay, and a bit, like this is my position, this is a bit, so it can have possibilities of getting either 0 or 1, okay. So if you are having 8-bit, 1 2 3 4 5 6 7 8 for 1 byte, so what you will have here, you will be having 2 possibilities, so on. So total possibilities will be for 8 space will be 2 to the power 8, so that will be 2 to the power 8, I think that will be 256, okay. So calculate this, you will get the value, so that will be 256. And if you are having 256 values, and what the thing you want to do, like here you are having 1 2 3 4 5 6 7 8, the total 8 bits are used for the character, and so that's why the range of values of character, when we will look here, so unsigned char is 0 to 122. So unsigned means this bit you don't want to use here the value either plus or minus without sign, so we will consider whole the bits, so that will be the range from 0 to 256. And if you want to reserve the value of this for either plus or minus, so apart from this, for each location you will be having 2 to the power 1 possibilities, that is either 0 or 1. So here you can have 0 or 1, here you can have 0 or 1, here you can have 0 or 1. So if you are going for 8-bit with signed values, so here you can have either plus or minus, so remaining only 7 bits you can use, 1 2 3 4 5 6 7, so that will be having value 2 to the power 7, so it will be 128. And if you are giving sign, so values of range will be from minus to plus, so minus 127 to 0 is also considered as a value, so plus 120 minus 128 to plus 127, because you are also considered 0 as a positive value. So in this way you can find the length of the other you can find the range of the other data type. Like
now let's calculate the size of int. Here the size of int given is, that is minus of signed int is minus 327682 plus 32767, and that of unsigned int is from 0 to 65535, and the byte required is 2 bytes. So how this is get calculated, we will see this. Now here what we will do, that is, we know the 1 byte is equal to 8 bit, so 1 byte is equal to 8 bit. So 2 byte will be 16 bit. So 2 byte will be 16 bit. Then for 2 bytes, I will write capital B for byte. So we will have 16 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now here, this is our data which we can write in 2 byte format, but if we want that should be signed, so we reserve this bit, that is the LSB of this bit, we will reserve this for either plus or minus, and other than that whatever positions we are having, all these positions, at each positions we will have possibilities of getting either 0 or 1. So here also we will have either possibilities of getting zeros and ones. In the same way, for each positions we will have possibilities of 2. So we in total have 16 spaces. One space is reserved for sign, so that is for plus and minus. So total remaining spaces are 2 to 15. So we'll calculate that possibilities are 2 to the power 15 and 2 to the power 15. I think that is, we'll calculate this. 2 to the power 15 is equal to 32768. So it is sounding good as that is given. So like to the power, it's 32768. Now as we are going from minus sign to plus sign, so minus, this will be the minus 3 range for sign in will be minus 32768, and in between we have 0. Now 0 is also assumed as a positive number, so we will have one less value in the positive number. Minus 32768 to 0 2 plus 32767. This will be the range of our n. And if you don't want to reserve our sign for integer, so in total instead of 15 we will be having total 2 to the power 16 possibilities, so that we will get the value of that as 0 to 65535. So I think you understood how to calculate the size of basic data type. So we'll move on to the next topic, that is what is data type. We in basic we know what are different data types are in float, char, void. So in type of data, here integers are used to store whole number. Size and range of integer type on 16-bit machine is minus 32768 to 32767. If we want sign of int, for unsigned int it will be 0 to 65535 and so on. So floating, in basic, like what is integer value? Any non-fractional values, they are called as integer values. Now if you want some fractional values, so they are written with the data type as floating type. Floating types are used to store real numbers. Size and range of integer type on 16-bit machine is from 3.4 e to the power minus 38 to 3.4 e to the power plus 3. I think you know how to calculate the size. I think you know by just knowing the bytes, how many bytes you will require for any data type. You can calculate the range as we have seen earlier. So you will get this value. If you go on calculating for 4 byte, what will be the range? Data type char. Char stands for character. Character type. Character types are used to store character values. Size and range of integer type on 16-bit machine. Now here its character type is 1 byte required for any character on any bit machine. That may be 16-bit machine, 32-bit machine, or 64-bit machine, or a compiler. Everywhere character size does not get changed. It is only 1 byte. And the void. Void stands for nothing or null or just empty. Void type means no value. This is usually used to specify the type of function, not for any variable. So how we can write the C instructions? Basically, 3 types of instruction there exist in C: type declaration instruction, arithmetic instruction, and control instruction. The purpose of each of these instruction is given below. Basically, what is instruction is, if I want to do some task, I will give instructions to computer. Hey, do this task, do this task. But I should have to give this instruction in the way that my computer will understand. So we are talking about that instructions. So type declaration instruction, to declare the type of variable variables used in a C program. Next, arithmetic instruction, to perform arithmetic operations between constants and variable. Control instruction, to control the sequence of execution of various statements in a C program. We use this control instructions. So these are the type declaration instructions. Like if you want to declare the type of variable I, variable j, so we will go for variable declaration. Like if I want to say, hey, I am having I, something in my program which will in future will store some value, but this value will be of type integer, that is non-fractional value, that can be 100,000. So I have to specify that what is the type of value it will going to store clearly, because it cannot happen like one time we will store integer value, other time we will store character value in the same name, in the same memory space. Suppose this is present in my RAM, so here the name of this size is R, so I cannot store at any time any value, so that will give you the compiler confusion. It get confused. Okay, so if I'm having integer value, what I will do now? If I'm having character value, what I will do now? I don't understand at what time I will have to do what things. So that's why, to avoid ambiguity or to give anything very clearly, we give the data type of I, and with the help of declaration. Here we type int I, so this is called as a declaration. We are declaring before using the value of I in your whole program. Hey, before using I, let's check what is the type of value you can store in the I. So that is the integer value. You cannot store char, float, any other value in the I. So that's we are declaring. We are, before using anything, we are declaring, hey, this is the type of value which you can store. So I think you understood. So this is whole this about. If you want to read this, pause the video and read the remaining part. Now we'll do the next. What is the arithmetic instruction? If you want to perform any arithmetic operation, addition, subtraction, multiplication, so many things you have in arithmetic operations, you will go for writing the formulas in the forms of variables, constant, whole, these things. Like this is one of the arithmetic instruction. So here I am just writing the whole formula, and when I did with my formula, I am writing semicolon at the end of line to denote the termination of line. So this is one of the arithmetic instruction. A C arithmetic instruction consists of variable name on the left hand side and equal to, and variable name and constant on the right hand side. So basically what we are doing by using this is storing whatever value we have on the right hand side into the name which we have on the left hand side. So this value will be get stored in the variable name at. These variables and constant together are called as operands that are operated upon by the arithmetic operators, and the result is assigned using the assignment operator to the variable on the left hand side. This is equal to is the assignment operator. See, arithmetic statements could be of three types. Integer mode arithmetic statement. This is the example. Here we are just taking integer values. Real mode arithmetic statement. Here we are taking some of the fractional values also. And the mixed mode arithmetic statement, here we have combination of both this integer values plus floating point values or fractional values. Though arithmetic instruction looks simple to use, one often commits mistake in writing them. So if you're writing this, so like this is legal and this is illegal, because what is the purpose of equal to? It will take whatever value you have on the RHS side, it will compute whole this thing on the RHS, and it will store that value into the name which is present on the left hand side, only the single name. So if you write this instruction, that will be mistake, because this value will be get stored in a k into l, but here we just want the single name. K into l is another, further it is the expression, so it is not the correct. We just have here single name, we just should have the single name, so that will be the correct. So these are some of the examples. Now what is the type conversion? And type conversion in assignments. It may so happen that the type of expression and the type of variable on the left hand side of the assignment operator may not be the same. In such a case, the value of the expression is promoted or demoted depending on the type of the variable on the left hand side of equal to. For example, consider the following assignment statement. Here my R is totally integer type, B is float, I means the meaning of this is that I cannot take any fractional values which is represented in the point format, and B is float, so it can take values which is present in the point format. So here in the first assignment statement, like we'll see the equation I is equal to 3.5, but our I was of int, and int can never take the fractional values, and here what is there, we have 3.5. The task of equal to assignment is to take the value from the right hand side and to assign it to the left hand side variable, not to the expression. So this value will be taken from the right hand side and it will be given to the variable name which is present on the left hand side, but the type of I is different and the type of this value is different. This is float type of value and this is int type of value. So here in the first assignment statement, though the expression value is a float, it cannot be stored in I since it is an int. In such a case, the float is demoted to an int and then its value is stored. The meaning of that is like here the compiler by itself will make the decision, okay, now I is of type int, so instead of taking 3.5 as a float value, so I will just consider whatever value I have before point in that value. So compiler will take only the value 3, and it will just store that 3 in I. So it will not store 3.5. So hence what gets stored in I is only the 3. Exactly opposite happens in the next statement. Here 30 is promoted to 30.0000, means the B is equal to 30 here, and the type of B is float. So what we will do, B is float, and here we are just assigning integer value, the value which is not present in the point format. So this is getting stored in B. So what will be get stored in B? 30 value should be get stored in B, but B is of type int, so instead of storing 30 we will convert the value 30 into the float values. So in float values, after point we just reserve 6 places for the number representation. So instead of taking 30 as it is, it will represent 30 as 30 point dot 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 30.000000, 6 times 0, and then stored in B. Since B is being float variable, cannot hold anything except a float value. So I think you understood the type conversion in the assignment. It will automatically get converted into the type which is present on the left hand side. L values and R values in C. There are two kinds of expression in C. L value expression that refers to the memory location are called L value expression, and L value may appear as either left hand or right hand side of an assignment. R value in the term refers to the data value, not the memory location. It will only refers to the directly to the data that is stored at some address in memory. An R value is an expression that cannot have a value assigned to it, which means an R value may appear on the right hand side but not on left hand side of an assignment. So here it is clearly given that R value may appear on right hand side but not on the left hand side of an assignment. Variables are L values because when we take the variables, we just have the name of that. So in that name in future we can store the values. So they are referring to the memory allocations. So they are just L values and the constant. So they may appear on the left hand side of an assignment, that is memory. Literals are L values. Literals, or we can say the constant values, are R values, and so they may not be assigned and cannot appear on the left hand side. Take a look at the following valid and invalid statement. If G is equal to 10. So this is the valid statement because we are storing value 20 into the variable G. 10 is equal to 20. Okay, this cannot be possible. We are here, what the statement is telling to you that we want to store value 20 in 10. So this is not possible. This is invalid statement would generate a compile time error. Int A is equal A comma B comma C. C is equal to A plus B plus 20. Okay, this is perfectly valid. The constant value we have in the right hand side part of your equation or that line. Now we'll switch to the different input output functions present in your C language. There are basically two types of IO functions, that is formatted and unformatted IO functions. So formatted and unformatted IO functions. The printf and scanf functions are formatted IO functions, means we can format whatever data which we want to see on the output screen on the monitor, or whatever data which we want to take from the user. That can be we can take that according to our choice, or we can display that according to our choice. Printf and scanf functions are inbuilt library functions in C programming language which are available in C library by default. These functions are declared and related macros are defined in stdio.h, which is a header file in C language. We have to include stdio.h file as shown in below C program to make use of this printf and scanf library functions in C language. Printf function, it writes or prints the specified content onto the standard output device, which can be the monitor screen. Scanf function, it reads the specified content or accepts the desired data from the standard input device, which can be a keyboard. Now, I think you have not understood very clearly what is the printf and scanf. We will take after some slides what is printf and scanf in detail, but for now, we will take what is a printf. Now, I want to print hello world on screen. Suppose I want to just print H on my output device by using C program. So how I should write the C program? So the thing which we should give that, okay, H is something which you have to provide as output on the output screen, that is your monitor. So this thing is done by the printf function. It will tell what is the thing, what is the statement which you want to display on the monitor. It will be written inside the printf. So for that purpose we will write the printf. So that will be the printf and opening down bracket, double quote, whatever statement you want to display on the output device, closing double quotes, closing round bracket, and semicolon. Okay, but the code of this printf is present in your stdio.h file, so that's why we include the stdio.h file, hash include stdio.h. So when you write this, you will get the output as H on the screen. So I think you understood somewhat. We will discuss this later in detail. Input output format. Basically, there are three types of input output format: formatted IO, character IO, and file IO. IO format, character IO, through which you can take the character by character as input. The functions are getC, getS, and getCH. Here we cannot format our character, whatever character we want, or how many character we want, because this function allow you to take only one value at a time from the user as an input. So we cannot format more than two values. We cannot take more than two values at a time. So that's why we say that this is unformatted IO input function. In the same way, unformatted output functions are the functions which just print the one value at a time on monitor. They are put C, put S, put char. If you want to format something, like if you want to print something and in between you want to write the values and you want to write paragraphs and so many things, so you will go for printf. Here you can format the thing, whatever things you want to display, that will be according to your choice, and that can be amount of the variables, values, things, that can be in ample amount of time you can write by using just single printf. And whatever things you want to take from the user, that can be 2 values, 3 values, 4 values at a time, that can be done by using scanf. So this is a formatted input function, formatted output function. And the file related input output functions are FF1. These are the file related input functions. These are file related output functions. So we'll see what is the task of input function. The format of scanf function. Scanf is purely used for taking input from the user and to store in the variables which are present in the address. So the format is scanf, some format string, and the address of variables. Format string, what this format string will consist of? In scanf, the format string should have only the format specifiers or placeholders. Other than that can be allowed, but whenever we are typing the input, we should have to type character by character in the same manner. So it contains only the format specifier, the scanf, %d, %f, %c. An address variable, it is obtained with the help of the address of operator. Like here, the meaning of this is like, hey, I want to take the value, some integer values, and store that, take the value, integer values from the user as input and store that value in the variable whose address is x. So here the meaning of this is, whenever you are typing, whenever your output, whenever you will compile your code which is having scanf, now here your cursor will blink, and what you are doing, you are just holding this one place for taking some value for the user by using this placeholder, and that is of type int. So if you type in integer value, suppose I am typing 10 and enter, so when you type enter or space, it will separate that value, and then this value 10, so whatever this you are typing 10 will be matched whether that is of type int. Okay, if this is of type int, we will store that in the address of x, and x may be present in your RAM somewhere. So when you type 10 and enter, it will automatically going to store the value 10 in your memory of x. So this is the thing which is happening. In the same way, if you want to take more than one values at a time, so this is %d value, integer value, and store that in x variable. Take the second value which is character value and store that in the variable y. Take the third value which is float value and store that in the variable z. So one by one you should have to type in the same order. The printf function, the printf format of printf is printf. Here you type format string and the list of variables or expressions. Now here you observe something, that here we are taking 3 values at a time, and that is allowed. So that's why we can say that whatever type of value which we want to take from the user, we can type, we can give, and we can take. So that's why we say that is a formatted input function. We can format this whole thing. We will see to the formatted output function, that is printf function. Printf format string, list of variables or expression. This is the format of printf. So what you can have in format string, you can have whatever things which you want to write on the output device, you can type in the format string inside 2 double quotes. And in printf or in scanf, we just have a single time opening double quote, and only single time we will have closing double quote. We have to write whole this thing within this 2 double quotes. We will not have more than 2 double quotes. So it will consist of character set, blank spaces, escape sequences, format specifier. So here what you are doing here, now let's look at this statement. The number of the building. Now this, what this thing is doing, a printf function will purely, it will see this value, and it will directly give it to display this value onto the monitor. Now this is your monitor, it will be displayed on the output device. Here its monitor is your one of the output device. You will get the statement as the number of building is. So the statement will be the number of building is, and after that will be what you want here. You want to hold this place for the values which is stored in the b. So instead of %d, you will be having the value of b. So that can be anything which is of type int. So this is one of the example. Now we will look at the unformatted array functions. The unformatted array functions do not have any format specifier. They are mostly used to accept and display only one character or one string. The different unformatted array functions are as getCh. This function is used to accept one character from the user. getCh. This function is used to accept one character from the user and echo it, display it on the screen. getChar. This function is used to accept one character from the user, echo it, and also wait after that for the user to press the enter key. PutCh and PutChar. This function are used to display the character on this monitor. The program for getCh function. So getCH function is present in conio.h, so that's why we are including hash include conio.h, and printf function is present in stdio.h, so we are writing hash include stdio.h. So inside main, whatever things we want, for whatever things we want the output of that thing, so we should have to write whole that thing inside the main function. So that's why we are writing main. So printf hello students getCH, whatever things we are typing. So after you will display this, you will wait for taking one character from the user. You will not display it again. Then this is the FPL lecture. Then this will be get displayed, and here we are just waiting for user. It will type some character, and that character whatever user type, that will not be displayed back on the monitor. So you will just have the hello student, this is FPL lecture as output. So we'll see what is the difference between getCH. The same thing happened, but it echoes that character. And here we'll see that if we if we are storing that character in some variable and we are printing that variable again, then we can get the value of that as the output. So press any key again from the keyboard. Here what you are doing, so here in getCH, it will not immediately gives you what is the character you have typed, and when you're typing getCH function, it will immediately give you what character you have typed immediately, and that you are storing again in some variable and you are printing. So you will also get here x is equal to b. So same way we have different functions. So here, what is the function of putchar? Here we have declared one variable whose data type is char, so it will just take one character at a time. So here initially we stored character C in C variable. So we are typing putchar, the value of character variable, that is of C. So it will print C, then putchar C. Then now here we have inside C the character as R, so it will print R. And then putchar C, the value of C is now Y character, so it will print Y. So in total, it will just print you C, R, Y separately for separate these functions, but we are not attached any space or any new line in between this function, so it will immediately give you, it looks like you are having a single word. Now we'll look at what are the different operators we have in the C language. So before starting operators, what we have in C language, we will look at what are different operators you have used in your school life. So these are different multiplication, division, addition, subtraction. So hierarchy of operators. While executing an arithmetic statement which has two or more operators, we may have some problems as to how exactly does it get executed. For example, does the expression 2 into x minus 3 into y is executed as 2x minus 3y or 2x minus 3y? Okay, but thank God we know what is the hierarchy of operators, as we know in from our school life. Similarly does that of this. So to answer this question satisfy, one has to understand the hierarchy of operator, and means what is the operators which will going to perform first, and then we will look for the other operators. So priority and our maths. So what are the different operators? You first of all solve your multiplication, solve first of all multiplication, division and modulus operator. Then you go for addition, subtraction, and once you complete addition, subtraction, then you try to store that value into the variables by using assignment operator. So determine the hierarchy of operators and evaluate the following expressions. So we will go for stepwise evaluation of this expression is shown below. So this is the whole expression what we have here. So now we will know how this is get calculated in mathematics. Now we will try to solve this expression according to our C language. So in C language, whatever things we are calculating, that is present on the right hand side, and whole result we will store the value of that into the one variable which is present on the LHS. So when we are assigning, when we are doing these things, whatever things we have after equal to, that will be get calculated from left to right, and we will go in to see what are different operators we have. So we have multiplication, division, plus division, plus minus, plus division. So in that we will try to solve this different operation in a hierarchy. So first of all, what we will do, we will solve this operation, that is multiplication, as we are going from left to right. And in that multiplication, division, plus all of this operator, multiplication is having higher priority. So we will solve that. So we will be having 6 division by 4 plus whole this remaining operation. Now in that we are going from left to right. So the next operator whose priority nearer to from left to right is, that is division. So we will solve this. We will get the value as 1 because our I is of type int, it is not float. So 6 divided by 4, it gives you 1 and not 1.5. This so happens because 6 and 4 both are integers, and therefore we evaluate to only the integer constant. So we will have the value as 1. So next what we will going to do, now here from plus we have from left to right, that is plus, division, plus, and so many operators. But in between plus and division, this operation will be performed first, so it will give you the value as 1. Again we will go from left to right, and then plus, plus, minus, plus, division. Okay, now this operator will be performed first among all others. Now it will give you the value as 0, as same discussed earlier. Similarly, 5 divided by 8 evaluates to 0, since 5 and 8 are integer constant and hence must return an integer value. So after this we'll go from left to right. We are just going from left to right after equal to operator. So here we are having plus, plus, minus, plus. So all these are having the same priority. So we will solve this one by one. 1 plus 1 will be 2. So then in this equation we are having 2 plus 8. We will solve this, that is 2 plus 8 will give you 10. And this expression we will solve from left to right. In minus and plus, both are having same priority. It doesn't matter which operation you are performing for the first time. So we'll solve this. 10 minus 2, it will give you that 8. And then in this expression we are having just only one operator, so we will get the value as 8. So finally 8 will be get stored in the variable value of I. So thus your expression is get evaluated from left to right according to which operator will be first evaluated. So that will be first evaluated, then the remaining operator will be evaluated, and so on. So finally we get the answer. So determine the hierarchy of operation and evaluate the following expression. So I will suggest you should pause this video and find the result, and in between if you have any doubts, here are the steps I have given. Now in the same, we convert a general arithmetic statement to a C statement. So these are some of the expressions which we have. Instead of taking multiplication as a cross, we write in C language as star. Instead of writing this thing, in math we just write this bracket multiplied by these things, but we should have to clearly specify every time multiplication sign separately. So in the same way, if we are writing 3x square, so we should have to write x square can be x into x, and 3x can be 3 into x. So we write 3 into x into x. So in the same way we can go for doing the remaining things. We can evaluate how this thing can be written in our C programming language as an expression. So I will also suggest here pause and see what are the different expressions you have. Now we will look at what are different operators you have in the C programming language. An operator is a symbol that tells the compiler to perform specific mathematical or logical functions. C language is rich in built-in operators and provides the following types of operators: arithmetic, relational, logical operator, bitwise operator, assignment operator, miscellaneous operator, and so many operators. We will in this chapter look into the way each operator works. Now we'll start with the first very basic operator, that is assignment operator. The assignment operator, the task of assignment operator is to assign a value and to store the value it into the things which are present on the left hand side. So it takes the value from the right hand side and it stores that right hand side value into the left hand side. The assignment operator assigns a particular value to a variable name specified. It is represented by equal to sign. On the left hand side, the variable name is specified, and on the right hand side, the assignment operator value to be assigned is specified. A is equal to 6 here. What this is meaning, it means that the constant value 6 is assigned to the variable A. Means 6 is getting stored in the variable A. Here A is equal to single quote Z. It means that constant value of character Z is getting stored in the variable A. So C language operators, that is unary operator. This operator is represented by the sign minus or plus, and we have so many operators. It requires the single operand, single data on which we will operate this operator to operate upon. Hence it is called as a unary operator. It negates the value of operand. Consider operand to be a variable, say A. When unary operates on A, that is, if you want to perform minus of A, so that is same equivalent to as that of expression 0 minus A. So these are some of the unary operators, which we will see this in detail. Some of the unary operators are minus, unary minus. Now this is typecast operator, logical NOT, address of operator, star for value of operator, this is scope resolution operator, size of operator, increment operator and decrement operator. Now unary operator, that is typecast. Now this is a program whole for your all unary operators except increment and decrement. So here what we are doing, we are declaring variable ABCR as integer values, X as some floating type of value and variable. Now here I am doing equal to assignment. Now A is equal to 2. Okay, in A what we have the value of 2. So A is equal to 2. Now what we are doing, B is equal to minus A. Now we have used minus unary operator. So instead of 2, what it will store, it will give the minus sign to this data. So it will store minus 2 in B. Now X, that is of type float. What we are doing here, we are converting this line. This is the typecast operator. It is used before the name of variable. So what this line is doing, it is taking the value of A, which is of type int, but as our X, which is present on RHS, which is present on left hand side, in which we want to store the value of A. Here X is of type float, so we cannot write X is equal to A because our A is of type int and X is of type float. So we should have to convert this value into some other data type, so which is of type of X. So the type of X is float, so we will convert this value, not the value of A, just converting the value of A. We are not converting A from int to float, we are just converting the value of A from int to float. So this thing can be done by using, take the value of A, which is of type int, and convert the value present in A to float, and don't store that float value into the A back again. So if we are storing the floating value in A, so this whole thing will be get changed. So this thing will never get changed in your whole program. So this thing will be kept as it is for the whole life of your program. Only the value of A, that is the 2, it will be converted into floating format. This is get converted. Your variable value A is not converted. This value is converted into 2.0000000, which is of type float. On this value we are performing type conversion operation, and this value will be get stored in the variable X. Okay, so means you're not, whatever things which were converted into the float value, we are not storing back it into the X again. So this never happens. This is the X value, and R is not of A, not of logical, not of any value which is other than 0 is 1, logical not of any value other than 0, that is 1, and logical NOT of your 0 is 1. Means that any value which can be plus value, minus value other than 0 is considered as a positive value. So logical NOT of that is, sorry, its logical NOT of that is 0, and logical NOT of 0 is 1. So here the output is unity minus is minus 2. Typecast we did in this line, so that is x is equal to 2 point this. Logical NOT of your r, that is 0, because r is two values, some values which is other than 0, so it will be converted into 0. Now here we want to use the address of operator, so we want to print the address of a. So here we have used placeholder as %u, so address of a as something like this. Size of a, now size of a will give you the value of size of variable in the form of bytes. So here in my machine, as my machine is 32-bit machine, so here it is showing me the output as size of a, which is of type int, as 4, and the logical NOT, the last operator, which is bitwise NOT. So to understand that, bitwise NOT of any value x is equal to minus of its next value, that is x plus 1. So here my value of a was 2, so bitwise NOT of a will be, the next value after 2 will be 3 and minus of that, so it will be minus of 2. If you are also calculating bitwise NOT of 0, so it will be minus of the next value after, what is the value we have after 0, that is 1, so minus of 1. So say type conversion, as discussed earlier, implicit type conversion, it automatically converts any intermediate values to the proper type so that the expression can be evaluated without losing any significance, called implicit type conversion. If the operand are of different types, the lower type rule is that if the operand are of different types, the lower type is automatically converted into the higher type before operation is processed. Explicit type conversion. Now if you want to specify the conversion of the data, then we go for the explicit type conversion by using this format. Use the, in bracket we use the data type and the expression or the variable directly. Here we don't know, this is the variable x of type int, y is the variable of type float. Now we have to calculate this equation, but this whole thing is present in float value, so everything will be get calculated in the float value y plus 10.5, but we want to store this value in x. We cannot store this because value of x is in and this whole thing is float, and implicitly what we can convert, the lower value, lower data type, that is can be converted into the higher data type, but this is higher data type. After int we have float, after float we have double, and so many things. So this is float and this is int, so we cannot convert higher data type into int immediately, so we have to give by our own code that we want to convert this into int. So we will take this value whole as it is. Before assigning this directly to x, what we will do here, we will convert the type of this value result into the integer value, and then this integer value will be given to the x. So typecasting operator, here are the example of this typecasting operator. So what we are doing, we are just taking, this is the float value, this is the float value, we are dividing these two float values. Before dividing, we are converting this into integer values, we are converting this into integer values. So instead of 27.3, we will have 27 divided by 3. Now whatever value we have, that will result into the 9, and the 9 is of type int. Now it will be get stored into the x. The next line what we have, that is we are again converting the 2 into float value, now 7 into float value. So instead of 2 divided by 7, we are converting into the float, so it will be 2.000000006 times 0, and after 7 also we will have 7 times same zeros. We are dividing this to now whatever things we have divided, we will hold that thing into the point format 0.285714. Now this value will be get stored into your A, and the type of A is float, so it doesn't matter for storing correct value. So you will have the output as 0.285714. So the next operator, unary operator, are increment and decrement operator. Many times it is required in a certain C program that a number is increasing or decreasing sequentially, means one after other. So plus plus means increase the value of variable by 1, and minus it decrease the value of variable by 1. There are also two types of increments and decrements. Pre-increment, if your plus plus is appearing before your variable name, so it will be pre-increment, and if your plus plus is appearing after the variable name, so it will be post-increment. So what is the task of this? Now we will look at the basic increment, pre-increment and post-increment. So here what it will do, before here it will first of all, suppose you are having x is equal to 3. So if I am writing plus plus x, so it will add one value in the value of x, that is 3 plus 1, and it will perform the addition, then it will store the value in x. So your x will become 4. Okay, now here what is the meaning of this? So here what we are doing, we are just printing first value of x. So we are just giving value of x immediately before performing increment operation. So your x will be 3, and then we are incrementing the value of x. So then your x will become 4. So the meaning is that you cannot, I think you are not understood very well. So we'll take in equation format, x is equal to suppose 3, and you are having a is equal to plus x, and how this thing will be executed separately, and b is equal to x plus plus. So x is equal to 3. So before giving the value from the right hand side to left hand side, all this thing will be executed. So here we will go for doing the plus plus x. So when we are looking at this, first is addition task. So we'll add one value in the x, that now x will become 4, and then is the x is present here, so your x will become 4, and wherever you have the variable name, it will immediately give the value to the corresponding variable which is present on left hand side, or if you are printing, so it will immediately print. So your a will become 4. Okay, now here b is equal to x plus plus. So here it will first of all, it will come at, we'll look at this from left to right, it will come at x first. So value of x is 3, and whenever you have x, it will immediately give it to b. Now here b will have 3, and afterward, after giving that value to the variables, it will increment the value of x. Now then x will become 4. In the both case, after execution of this, x will become 4, but there is the difference in assigning that value to the related operator. So here the value of a, like a is 7, I am printing that is 7. So I am decrementing the value of a by 1. So I will have value as output as 6, because what we are doing 7 minus 1, and then we are printing the value of variable a. Now this will be get stored in your a, that is 6, and then you are printing the value of a, that is 6. Now here what we are doing in a minus minus, first of all you have a minus minus, so you are printing, whenever you have variable name, you are printing the value of a, which is 6, and then you are decrementing the value of a. Now a is equal to 6 minus 1, that will be 5. But whenever you have the variable name, only in that case related operation will be get performed, whether you want to assign it or whether you want to print this value. So here this value will be get printed immediately, and then value of a will be reduced. The same here, minus minus a. Now our a was 5, then first we are reducing one value from this, your a will become 4, and then we are doing the a, means here your a will be get printed here. So your a will be a is equal to 4. The same way, now here when we look at this expression plus plus and minus minus, so here pre-increment or pre-decrement are having greater priority than its post-increment or post-decrement. So first of all, in your expression you will calculate the pre-increment or pre-decrement. So what is this value? You will go from left to right. Here in brackets you have this plus and plus, plus and plus plus. So first of all brackets are solved, so x will become x plus plus. So here z is equal to, we are doing x plus plus, so we will just immediately write the value of x, that is 4, and then value of x will be increased, that doesn't matter in our expression. So it will be z is equal to 4, and then value of x will be 5. Now plus we have minus minus y. Now what we are doing, we are first of all we are subtracting the value of y, that is 9, so we are subtracting, that is 8, and then we are doing y, so it will be assigned to the expression. Now your y will become 8. Okay, then plus y. Now your y is 8. So it will coming out to be 8 plus 8 plus 4. It will give you the value as 20, as present here. The same way you will go for calculating this. Now, how you will calculate this equation? You are having z is equal to minus minus x plus y minus minus, and these are in brackets. So we will solve the bracket first. So what we are doing, z is equal to minus minus of x, so we will decrement one value from x, will not give it to z immediately in expression immediately. Now your x before that was, here we have incremented value of x, so our x became 5, and here we decremented the value of y, so your y had become 2, instead of 9 it had become 8. So now your x is 5, so we are just reducing one value from x, so your x will become 4, and then your x is coming, so we will now give the value of x, what is we have right now, to the expression, that you will give the 4. Then we are doing plus x, now x is 4, and then plus, here you are having y minus minus, so here y is appearing, the name of variable is appearing first, so we will immediately give the value in the expression, so that is 8, and then we are decreasing its own value of y, so your y had 8, value as 8, so y will become 7. So but this will be only stored in the y, it will not given to the expression. So we will calculate this, we will get the value as 4 plus 4 plus 8, so I think this will be around 60. Yes, we are getting the output, exactly correct output. Now different C language operators, we are the binary operators. They are addition, subtraction, multiplication, division, and modulus division. These are arithmetic binary operations. Now this you know already, we have discussed this already. Multiplication, division, modulus, these are get executed first. Then we have plus and minus will be executed. But we know for multiplication we use star operator, for division we use slash operator, this operator, and for performing modulus operation we go for percent sign. Here if you're typing here, we will look at this example, a is equal to 5 and b is equal to 2, a is equal to 5, b is equal to 2. What we want to divide 5 by 2, and we want the remainder after this division, remainder. So for that purpose we use modulus operator, 5 mod 2, it will give you the remainder what we have after division of 5 with 2, that value will be get stored in this percent operator. So 5 divided by 2, 2 2s are 4, and we are remained with one value. So your remainder is 1. So your result of this will be 1. Different relational operators. These are also binary operators, that is, they require two operands to perform their operation. Relational operator is also called as comparison operator. Now this is not equal to, greater than, less than, greater than equal to, less than equal to, equal to. For equal to we write double equal to, we don't write equal to. Equal to, single equal to is for assigning, take the value from right and directly store it on the left hand side. Double equal to is used for comparing on the both side whether the values are equal or not. Now you see different relational operators.
Now let's look at relational operators. So as we have studied different relational operators, so they are less than, greater than, less than equal to, greater than equal to. For equal to we write double equal to, and for not equal to we write exclamation mark equal to. So example, x is less than y, that is x is less than y. If this condition holds true, then the output will be 1, and if this condition becomes false, then output will be 0. 0 means false and 1 means true value. Second example, x is greater than y, that is x is greater than y. If this condition holds true, then the output will be 1, and if condition holds false, then output will be 0. X is less than equal to y, that is x is less than equal to less than or equal to y. X is greater than or equal to y. X is equal to y, and x is not equal to. If this condition holds true, then the output will be 1. If x and y values are different, then output will be 1, and if both are equal, then output will be false, means 0 value. So this is one example. Now here we are taking ABC as a 3 variables of type integer, and we are inside the main function. Now we have declared the value of A as 2, and we have set the value of B as 7. So here we will check one by one. We have print the value of A as 2, value of B as 7. Now here in the printing, what we want, instead of variable we are just writing the instruction itself. So that is A is less than B. So whether 2 is less than 7, yes, it's a true value, so it will result a 1 value in the output. Whether A is greater than B, 2 is greater than 7, no, it is false condition. So in that case it will give you output as 0. Whether A is less than or equal to B, 2 is less than or equal to 7, yes, it will print 1. Whether 2 is means A is greater than equal to B, whether 2 is greater than equal to B, so it is a false value. 2 is less than equal to 7, and 2 is greater than equal to 7, it is false value, so it will give you 0. Whether 2 is equal to 7, no, so it will give you the value as 0 as a output. And whether 2 and 7 are not equal, yes, 2 and 7 are not equal, so it will give output as a 1. So the next operator is the ternary operator. The ternary operator is the commonly known as conditional expression operator. As the name ternary operator suggests, this operator requires 3 operands to operate on. The sign used to denote this operator are question mark and colon, or we can say the question mark followed by colon. This is the sign used to represent the ternary operator. The first operand is placed before the question mark is condition, and the first operand is evaluated initially. The second operand is placed in between 2 signs, and the third operand is placed after colon. So we'll say this, how we can write this ternary operator. Now first of all we write what is the condition. After writing the condition, we never write the variable. After writing the condition, we give the question mark. Okay, now if this condition becomes true, what expected value or expression we want to continue with, so that is written after question mark. This is when your condition becomes true, and if your condition becomes false, what is the expected value you want to get or expression you want to execute, that is written after this colon, and your ternary operator ends here. So this is true value for given condition, this is expression 2 is a false value for the given condition. The remaining 2 operands, expression 1 and expression 2, are equation on the constant value. They are evaluated as condition if this condition becomes true, then you will calculate this expression 1. If this condition becomes false, then you will directly go to the expression 2 and you will calculate the expression 2. You will skip this expression part. You will not consider the expression 1 if your condition is false. If the result of the condition evaluated comes true, then the expression 1 is evaluated. If the result of condition is false, then the expression 2 is evaluated. Expression 1 is ignored. So program for looking how ternary operator will looks like. Here we have declared 3 variable a, b, c, and initial value of a is 3, b is 7. So we are writing this c is equal to whole this thing. Now equal to operator, it takes whatever value you have on the right hand side and it assign that value to the left hand side variable. So we will first of all calculate this whole this thing. Now here given is that a plus 4 is equal to b. So a plus 4 is equal to b. We are checking on the both side this value and this value whether they are equal. A is 3, so 3 plus 4 is equal to 7. So 3 plus 4 is 7 is equal to 7. Yes, it is true. If this is true, we will going to look for what is value written before colon, so that will be 1. So your c will have the value as 1. So this is the output of first expression. And for the next expression, we have c is equal to b is less than a. If this condition becomes true, then we will calculate this part. If this condition becomes false, then we will calculate this part. Okay, so we'll look what is b. B is less than a, so 7 is less than 3. No, this is false, so we will directly go to the part which is written after colon in this part. So that is your b divided by a. So that is 7 divided by 3. It is 3 2s are 6.2 point something, but you are calculation on integer value, so you will have only the value as 2, and this will be get stored in your variable c. So your c will be 2. So I think you understood this now, how your ternary operator will be get evaluated. Now here, as this expression is becoming false, so this value will be get evaluated after colon, and here your expression is becoming true, so your value before colon will be executed, or expression will be executed. Now the logical operator, the word logical stands for answer can be either true or false, and your logical operator perform operation on the logic of your both operands. It not see the what are the values, it never perform operation on the values, it perform operation on its logic whether it's true or false. In other words, the output of logical expression or equation will be either 0 or 1. It cannot be any other value other than 0 and 1. So these are different operators, logical and, logical or, logical not. So program for logical operator. So here when we are performing logical any operators, so we should have on the both side the condition, and we are just checking whether they are equal or not, or whether what operation we are performing that should be get executed. So here we are taking example on logical operator. A is 2 and b is 7. In this expression what we are doing, we are just checking the AND value on the both side, logical AND. This is not the binary, and this is logical AND. So whether a is less than b, 2 is less than b, yes, its logic value is 1. Whether b is not equal to 0, 7 is not equal to 0, yes, its logic value is 1, and we will look for this AND gate. So logical value of AND will be 1 only when all the inputs are 1, then only you will get value as 1. So here both the values of operand on the both side are 1, so you will get the output as 1. The next is your logical AND on the another condition. A is greater than b and b is greater than equal to 0. A is greater than b, this is false, so it will give logical value as 0. B is greater than equal to 0, yes, it is 1, but logical AND will give you the value 1, result 1, true only when your all inputs are true or 1. So here in between this both are not true, so I will get output as 0 for all other values. So here you will get the output as 0. The next is you are checking logical OR. So this is the OR table. You will get, if any one of your input is 1, so you will get the output as 1 in logical OR. So we will check here A is equal to B and B is greater than 0. So you are just checking what are the logic values of this. A is equal to 7, whether 2 is equal to 7, no, so it will be 0 or false. Whether B is greater than 0, whether 7 is greater than 0, yes, so it is true, so it will give you the value as 1. But what we want here for logical OR, any one, at least one value is 1 in between all the inputs, so we will get output as 1, so it will give you the output as 1. So this is your third value, you will get output as 1. Now we will go on checking the next value, that is A is not equal to 0, logical OR with A is greater than 0. A is not equal to 0, that is 2 is not equal to 0, true, so it will give output as 1. A is greater than 0, true, so it will give output as 1, and both the inputs for logical OR are 1, so it will give output as 1. So you will get the output as 1. And the last operation, which is not of your anything, any expression, logical value. So A is greater than 0, whether 2 is greater than 0, yes, so it will give output as 1. And we want to perform not on 1, so not of any value other than 0 is always 0, and not of only 0 is 1, so we'll get the output as 0. Binary bitwise operators. Concept of bits, as you know, one bit is equal to the whether you are getting value as 0 or 1. Binary number system have two values. Here you will have either 0 or 1 at any place, so these values are called as a bit or bits. The number system here given is that in binary you just have a range or capabilities of taking all the possible inputs are either 0 or 1. In octal values you have total 8 range, they are from 0 to 7. You cannot take any number other than 7, 0 to 7, that is you cannot take 9, 8, 10 in this octal number. In decimal you can take any number from 0 to 9 range. In hexadecimal number you have 16 possible range, that is from 0 to 9, and for 10, 11, 12, 13 we write the capital letters A, B, C, D. For 10 we write capital A, for 11 we write capital B, for 12 we write C, for 13 we write D, and for 14 and we write E, and for 15 we write capital F. So from 0 to 15 we will have total 16 range. A nibble is a 4-bit, a byte is a 8 bits, and word is a collection of 16 bits. So this is when you write any number, so this is the part of LSB and this is called as its MSB. So this is the grouping of bits and it is a grouping of a byte. Now we will look at what are the different bitwise operators. So bitwise operator can perform its task on unary operator, or it can perform the operation bitwise on the two data. So they are logical and, bitwise logical and, bitwise logical OR. Here bitwise logical XOR, one's complement, right shift, we are shifting towards right, and this is left shift. So we will see this one by one. Now bitwise AND will perform binary AND on its binary data. So as discussed earlier, your result of AND gate is 1 when all the inputs are 1. So when you are performing any bitwise binary operation, what you do, you convert your values into binaries and then you perform the operation. So here we will take one example, like here we are declaring ABC as 3 variables, value of A as 21, B is 37. So in 21 will be written in the binary format, 37 will be written in binary format, as we want to perform binary operation on 21 and 37, and we are writing A and B. So when you are performing 21 and 37, so you are not performing AND gate on 21 and 37 directly. What you do, you will convert this into binary first, 21 and 37, and then you will perform bit by bit checking of logical AND gate. So here 21 is represented as 10101 and 37 is represented as 100101. So we will go for checking the LSB part, this first bit, that is 11. So for AND gate, result is 1 only when your both the inputs are 1, so it will give you the value result as 1. So for 00, it will give you the result as 0. For 11, it will give you the result as 1, and for 00 result will be 0. For 10 result will be 0 for 1, and this will be assumed as 0, result will be 0. So it will give you the result as 101. Now while displaying the output, you will not get the 101 as a result or of this operation, that is C is not equal to 101. Instead of this, value is get converted into its decimal internally by compiler itself, and it is representation of number 5. So 5 will be stored in C. So you will get here the operand 1 and operand 2 AND gate, you will get the value as 5. So in the same way, we will perform the next operation on the logical bitwise OR. So here we are taking three variables A, B, C. A is 21, B is 37, and we are performing C is equal to A or B, logical binary OR, not logical OR. It's performing logical operation of OR but on the binary data of A and B. So we will convert the value of this is my A, this is my B. Now 21 will be converted into binary format, 37 will be converted into its binary format, and then on bit by bit from right to left, or from LSB to MSB, we will check each bit corresponding bits of two numbers whether they are following the operation values, and depending on this you will get the output. So OR gate will give you the output 1 when any one of the input value is 1. So here we will check 1 1, it will give you the result as 1. 0 0, no value is 1 in this two input, so it will give you the result as 0. 1 1 will give you the result as 1. 0 0 will give you the result as 0. 0 1 will give you the result as 1 because at least one value is present in between these two, and last one will be compared with the 0. So you will get the value as 0 1, it will be 1. So whatever number you are getting, that is 110101. Now this is representation, binary representation of number 53. So instead of getting this value, you will get 53 as a result, and after performing this operation it will give the value as 53, and 53 will be stored in your C. So you will get the result as 53. In the same way, we perform XOR operation. In XOR, it will give you the output 1 only when both the inputs are different, you will get the output as 1. So the same data we are performing XOR operation, 1 1 will be 0, both are same, 0 0 will be 0, both are same, 1 1 is 0 because both are same, both inputs are same. Here this is input and this is our output, this is value of A and B. Now 0 0, both inputs are same, so result will be 0. 1 0, both inputs are different from each other, so it will give you the result as 1 1, and this is assumed as 0. Both inputs are exactly opposite of each other, so it will give the output as 1. So you will get the result as 110000. Now you will never get the 110000 as a result. Instead of that, you will get its decimal representation, that is number is 48, and here you will have 48 as a result, and that will be get stored in your C. So you will get the output of A XOR B. This is not used for power, this is purely used for XOR on binary data, so that will be 48. The next operator is bitwise NOT. So it perform operation on the single data. It is bitwise unary operator, as discussed earlier. Bitwise unary operator, that is NOT. So bitwise NOT of any value is equal to minus of its next value. So if we are performing C is equal to bitwise NOT of A is my 21, A plus 1 will be my 22, and minus of A plus 1 will be minus 22. That will be stored in a negation of A, or bitwise NOT of A. So you will get the result as bitwise not of A is minus 22. Now bitwise right shift operator, here bitwise right shift operator is used in the format of data right shift, and by how many bits you want to shift that data, you write in this fashion. You write data or variable, you will right shift by how many bits. So here I am writing A is equal to A right shift by 4. So it means that you are shifting A by 4 bits towards right. And here A value of A is 63. So the binary representation of 63 is 111111. Now here when you will shift this value towards right by 4 bit, you will lost rightmost 4 bits. So in simple words, just delete rightmost this many bits, that is 4 bits, and whatever number you get before that, that will be your result. So you will just have 1 as a result. So 111111. So here 63 is 111111. In binary we want to delete rightmost 4 bits, 1 2 3 4. Now whatever you are getting as a result, that will be your final result. So that is 11, and 11 is binary representation of number 3, so you will get the result as 3 when you're shifting your 63 4 times binarily by 4 bit. Or in simple word, we can say that this is number 63. When you will shift this towards 1 bit, so this is my range, so my number 1 will be get removed. So instead of this place you will be having 0, so this is shifted, this is shifted. Now again shift, one time we have shifted towards right this number, now again shift this number towards one time towards right, so that will be 2 time right shift. So you will have here 2 zeros. Again for the third time we are shifting towards right to this number, so you will have 0 0 0. This is shifted towards this place. And now the fourth time you are shifting this towards right, so this number will be removed, this will be get present here. Now this number will appear here, and all the previous location will be set as 0. So in simple word, we can say that just remove the leftmost or LSB, that many bits we want to shift towards right. Program for bitwise left shift operator. Now we have understood how we will shift towards right. When you shift towards right any number by that many bits, so that many bits of that number will be get removed, and we will see exactly opposite of that is left shift operators. So here the format of left shift operator is same as that of right shift operator, that is data or variable on which we want to perform left shift, and followed by this will tell you by how many bits you want to shift this data towards left. So here we are taking A as 10. Now we want to store A, we want to rotate our A towards left by 3 bits, and we are storing the same value in A. So binary representation for 10 is 1010. When you will shift your 10 towards left by 1 bit, you will get at this place 10. When you will shift this whole value towards left by 2 bits, you will get the LSB, 2 bits of LSB will be 0 0. When you will shift this for the third time, your LSB 3 bits will be set as 0. So in simple words, if you are shifting your any number towards left by that many bits, so just add on the LSB part that many zeros. So here I want to shift this number towards left by 3 bits, so I will add 30 as on the LSB part of my input, given input. So whatever I will get, the final, that will be result. So your LSB of this will be 10100000, that is the number 80. Whenever you left shift any number towards any bit, so your result will be greater value than your input, and whenever you shift your any number towards right, your result will be lesser value than your input value. So this is different operators we have seen, and this is its precedence and associativity of operator. Associativity means generally simply two kinds of associativity we have for any operator, whether for performing any operation you are going from left to right or you are just calculating from right to left. So when you perform plus plus minus or any operator, just take an example of size of operator, size of your suppose variable a. So here we calculate, we go from right to left, we take the variable, we calculate the size of a and we calculate the size of a. So it is associativity, we go from right to left when we calculate this operation. And for all other operators other than equal to and unary operator, associativity is from left to right. And this is the precedence, means if you have minus, unary minus, or just take example unary one's complement, and if you have less than operator, so in between these two operator you will first go for calculating this value, so because it is having higher priority than less than operator. And the same way we have the comma is the least priority operator. Comma is just simply used to separate more than one expression. The last operator is the comma operator. Now comma operator are used to link related expression together. For example, if you want to declare all the variables whose type is int, so we write int a comma b comma c comma d. This all the expression are related. That can be expression, can be a variable value, or that can be a bigger expression. So to link same kind of expression, we write the comma operator and we separate them by using commas. And the last, size of operator. The size of operator is written as size of the variable name. Here instead of variable you can also take the data type also. So that is, the task of this size of operator is to take the variable name or data type, and is an unary operator. It performs operation on only the single value which returns the size of data. That can be constant, this variable can be constant variable, array structure, or even a data type in the terms of number of bytes required in your machine. So size of variable, this is the syntax for writing the size of operator. So here we will take, just look at the simple example, like we have declared the variable int a. Now a is integer type of variable, and here we are printing size of int is equal to %lu bytes. So here size of, you can also take %d also here, bytes. So and what we are displaying, we are just displaying the size of a. So a, size of a required in your machine, that in how many bytes. So for integer, my machine is 32-bit machine, or my compiler is 32-bit compiler. So instead of giving the 2 bytes or just 2, it gives me the value as 4. So that is 4 bytes. So another example of size of operator, we are just taking variables of int a, float b, double c, char d, and we are taking, this is array, here it is storing 10 different values of integer. So size of a, variable a which is integer, it is 4 byte. Okay, size of b, that is float, that is 4 byte in my machine. Size of character, size of double, c is my double type, so size of double is double as that of your float, so it is 8 bytes. And size of char in any machine, whether you are using 16-bit machine, 32-bit machine, or 64-bit machine, only the thing, the size of character will never change, it will always be 1 byte. And the last, you are displaying size of e, which is the array. So it has 10 elements, 10 for each element. In int you require 4 bytes, so 4 into 10 you will be having total 40 bytes for this particular thing. So operator precedence, like we know, suppose we will take this example, in mathematics you solve multiplication first and then you go for adding the numbers. So the same way in which we perform the operation in the C language by using which operator should be executed or should be performed first, and then we go for which next operator. So the operators which are executed first, they are having higher precedence, and the operator which are performed after execution of this operator, so this is plus operator and 7 operator. So here multiplication is having higher precedence, so multiplication will be performed first, then we go for addition. So this is operator precedence chart. So this is the list. Here the brackets are solved first, and this list priority operator is a comma. At last the operator comma is executed. The only these two operators, these all are unary operators, they are having associativity from right to left. We calculate from right to left. Like if you want to perform address of A, so we take the variable A, and then we go for finding address of A. So we go from right to left, and also this equal to assignment operators are having associativity as from right to left. All others operator other than unary and assignment operator, they are having associativity from left to right. Or just take example like A plus B. For performing addition, we go from A plus B. We never go B plus A. So we always go from left to right. So this is associativity of all other operators. So see expression. Now this is the example. We have already solved this expression, some of the expressions, how you can solve this expression. Expression in C is any valid combination of operators, constant, functions and variables. Expression is evaluated using precedence and associative rule of operators which we have in that expression. So how we can define the constant? We can define constant by using hash define or constant keyword. So hash defined. Now we can define constant. Suppose instead of 10 I want to take 10 as another name, so I will write hash define the new name for 10, that is length, and the value you want to rename, that is 10, or that can be expression. So whenever I write a length, so this is assumed as 10. Whenever I write width, by using this it is assumed as 5. So this is hash define. It just hash define just gives you the format for hash define is hash define identifier and the value or expression. So for this value or expression you are giving just a simple or other different name which you can use in your whole program for the whole expression or value. This. Now to use the constant keyword, you can use constant prefix to declare constants with a specific type as follows: constant, then data type, variable is equal to the value. Now this value will never get changed in your whole program. So here I am declaring constant int length is equal to 10. So I will never change the value of this variable in my entire program. That will be set as 10, as because I have written constant keyword, const keyword before its declaration. C format specifier. There are different C format specifier or placeholders, which are %C is used for character, %D is used for decimal integer, %O is used for octal integer, %X for hexadecimal integer, %U for unsigned decimal integer, %LD for long int, %F for floating point, %LF for double or long double, %E for exponential floating point, %S for character string. So these are some of the example. If you want to print %, only the exception you will have to write double %, only then you can print the single % as an output. And all other than this, like if you want to print the 17 constant value, that is integer value 17, you can write either %I at this place you or %D here. If you want to print unsigned 17, so you can write 17U, U for unsigned int, % you will write %U. Or in other case, for printing address of any variable, you will also use %U. %O, now here octal value of 70, this is mistake, like we should have 017, so it will print the octal value of 17 into its decimal format, that will be 21, and hexadecimal value of 26 Here how 17 is represented in octal value, so that is 21. What is the value of 26 in hexadecimal format? That is 1a. What is the value of 26 in hexadecimal format? But here instead of ABCD we are writing capital ABCD, so that will be 1 capital A. And how we can write 3.14 in float %f by using this. After point we have 6 spaces reserved for the numbers, and so on. There are different C storage classes. They are auto, register, static and extern. For understanding this concept, I will show you the program. Now here we are going to the terminal, and in home directory we will save our program. So here it's a blank directory. Now we go for a terminal, and here we can type our program. So in terminal we will first create a file. Now type gedit file name, that is a.c, and in that what we will just take simple look at simple program. So I will write the simple program to print hello world. So hash include stdio.h, because I want printf and scanf. So then void main, then write the code, that is printf, and here we will display the value of a variable, that is int a is equal to 10. So in printf we will just print the value of a, that is value of a is equal to %d. Here we will hold this place, that is %d, for the value of a, and save the program, close the window. Now compile your program by gcc your file name, that is a.c. Here I have not given any output file name, like after compilation in which file you will store. So by default you are having a.out as your output file. So we'll see what is inside a.out. It's whole the thing is the binary code. Now we'll execute that by using / and file binary file name, that is /a.out. You will get the output as value of a is equal to 10. So the same thing we'll open our C program, that is value of a. Now we will give new line. For new line we have \n before and after the statement. Like % is used for holding the variable's value of a. Save program, close the program. The same program with the new line given, compile and execute. You will get the output value of a is C10. Now what we will do, by default all the variables are auto storage classes. Now we have declared auto extra and you are saying that the value of variable a is 10, because auto, without auto also all the variables are auto. Now here we will write the storage class as register. So when you typing the register, we'll compile and get the output. When you type the registers, your variables are stored inside the register of your CPU. Normally your all the variables are stored in main memory. Now that is the difference. Now what we will do, for taking the example of external storage classes, we will copy that int a is equal to 10, and we will store the value of int a is equal to 10 in other file. So we'll create new C program file. Now we'll cut this code and we will paste this code in another C file, that is b.c. So we'll paste here. Now here we know what is value of a, that is 10, and that is variable a. But we have to make the changes in a.c file. Like here we are using the variable a, but we don't know where exactly that is stored. Here we have not declared any variable a.c, that is stored in b.c. So we should write that with using, hey, I'm using some external variable whose value is stored in some other file. So for that we have to declare the variable as extern, and data type of that is int a, but value of a is stored in b.c. So when we type this, it knows like it is coming from other file, and at the time of compilation you have to give both the file name. So gcc a.c, here it's the file a.c, and we'll look at the b.c what we have. Now we will compile both this file at once. Now gcc a.c space b.c, and we'll get binary file. From that we'll get the output /a.out at set 10. Now This is the example of all the storage classes. Now to know the basic thing how you will take the input from the user, what we will do, we will create the new program and we will make the changes and then we will write the scanf. So we will delete all these things, that is we will delete this int a, and what we will do here, yes, static is remaining storage classes, so we will just look at how static was. Static is keyword used before any variable. What it will allow, it will just allow you to set any variable's value only once. It initialize any variable value only once, and whenever you are using that values again and again, what is the recent value you are having in that variable, that will be stored. So we'll take one other function like add add, and here we are printing the value of a in this function. So we'll save and compile, and let's see what happens. And what we want, the value of add function, in the add function we are printing the value of a. We want to print that for the 3 times, so we'll call the function 3 times inside the main function by using for loop, and inside we'll write just call to function add, then yes, function add semicolon. We'll save and close and we'll compile this, and oh, we have an error. We not declared the variable that is declared in main, but that is not declared in function add. So what we will do here, we will copy the declaration of, cut the declaration of variable a. We will globally, first of all we will see how we will do the globally. When you select the global declaration, your value of variable a will be get changed. We are doing a plus plus in add function, so initially value is 0, then 1, then 2, then we'll make the changes. Now we will use static variable. Now we will just declare this value inside the main function. Inside main we will just declare int I, and inside add we'll declare int a. So this is int j. Now here, before the variable a declaration inside function add, I have not declared static. So whenever you will go in add function, whenever it will be called and a set to 10, it will freshly assume value of a as 10 every time, at every call. So we will save this and compile, and the output will be, I think, 10 10 10, because every time when we are going in add function, it is assuming the value, it is setting the value of a as 10, and this, when we type static, this int a is equal to 10 will be executed only once, and whatever the new values of a will be updated. So that is 10 11 12. I think you have understood what is the main difference between static, auto, register and extern. Static is used to preserve the values of your variables in the function calls. Auto is just like auto declare automatic increment of values or in the function. Extern is used when you are using any value from the external variable. And here we'll just take how your scanf works. Scanf is one of the input function. Here we wait till we get some value in scanf. Now here I'm typing scanf %d ampersand a. I am waiting for %d value which is of type int, and that type of int value is of a. So when we are taking that %d, we will take the values and store at the ampersand a, that is address of a, and then we are repeatedly printing that value. So at the printf we are typing %d, that is the value of a. So we'll compile this and we'll see what is the output. So /a.out. Now here it's blinking, it is waiting when we will give the input value, and that should be of type int. So I have typed the value, and when I am typing the value, immediately it is giving me the output. Thank you. Enum or enumeration. An enumeration is a user-defined data type that consists of integral constant or integer constant. To define an enumeration, keyword enum is used. The format is, we will write enum, the name of variable we want to declare as enum, that is flag, and what are different possible values for that. So here name is enumeration. The name of enumeration is flag, the enumeration is my flag, and constant 2, these are the values of the type of flag. And here I have not set any values, so it will be first value will be always set as default value as 0, second will be 1, and so on. You can change default values of enum element during declaration. So here what I want to tell that, hey, I'm using some suit name which is used for storing integer values. So instead of 0 I can write club in my program, instead of 10 I can write diamonds in my program, instead of 20 I can write hearts in my program. So just for giving another name for integer values, you write enum. So we will take example. Before using anything we declare the variables. So here we are just declaring week as some enum or collection of the names which are just storing the integer value: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So I have not set any value, that is Sunday is equal to 0, 1, 2, 3, anything. So by default value of first variable in the week, that is in the enum collection, will be 0, second will have value as 1, third will have value as 2, this will have value as 3, and so on, plus 1 for each the values. Now here what we want to take variable of this type, so we should declare that variable. Today is variable whose data type is enum week, so it today can take any value from this collection. So today is equal to Wednesday. The value of Wednesday is 3, and what we are doing this value plus 1, so you will get the output as today plus 1. So 3 plus 1 will be 4, so day is 4. Enum is used to define a set of constant of type int, as we discussed the example earlier, and type def is used to define new name to your existing data type. So here I am just taking the example. You have type def, your basic data type, and what is the new name you want to give for that data type, that is number. For type here I am writing type def int number. So whenever I want int in my program, I can also write a number. So that doesn't bother ki whether you're writing int or number, because he already know, your compiler already know what is number. Number is the another meaning or another synonym or another name for your int. By using type def, we can just define or we can just rename only the types or only the data types. Typedef is a keyword used in C language to assign alternative names to existing data types. It's mostly used with user-defined data types. When names of data types become slightly complicated to use in program, following is the general syntax for using typedef. Typedef existing data type name and what is the alias name or the name which you want to give for that data type. So we'll take example typedef unsigned long. For this I want to give the another name as ulong. So whenever I will want to declare the variable of data type unsigned long variable, suppose ij, instead of unsigned long I can also take ulong. So the another name for unsigned long. The above statement defines a term ulong for an unsigned long data type. Now this ulong identifier can be used to define unsigned long type variables. Thank you.